I think at times it's better than others. So if you look at your review worksheet, so if you could take out the chapter 2 review worksheet. And we're going to go to number 8. Not 8, 9. So we're going to look at number 9 first. Number 9 actually wants us to do a couple of things. So number 9 wants us to graph this function, y equals 2 absolute value of x plus 1 minus 1. And then it says to label the vertex, which is pretty easy. But it also wants us to find the intercepts. So it's really asking us to do a few things here. So let's talk about the vertex part first, because we kind of need the vertex in order to graph. When you look at an equation, we now have this form of the equation we're going to be using throughout the year. And that form has the vertex kind of embedded inside of it. Let me change these numbers here. So that form is the h and the k. So thinking about h and k, and we'll see that h and k in the problem, various graphs that we look at. So our vertex, we have a -1 for h and a -1 for k. And you gotta be really careful with the number inside. The number inside is x minus as the general equation. So this vertex is at -1 and -1. So it's moving left, even though it says plus, it's really the opposite, x minus the -1. And then it's also going down. So I'm gonna plot that point first. Go left 1, down 1. And then if we look at the number in front, that number in front is our slope. So on the right side, the slope is as written. On the left side, the slope is opposite. What's the shape of this graph going to be? What should it look like? Leah, do you know what it'll look like? A V. Yeah, this graph should be a V. So the graph is going to go up 2 over 1. That's my positive slope. The graph is still going to go up 2, but it's going to go backwards 1. When I go backwards 1, that's how I get the negative slope. So both of them are going up, and then they're going left or right. Up 2, left or right, up 2, left or right. Any questions on that part? So we have the vertex, we have our graph, but it says we also need intercepts. And there are 2 types of intercepts. We have the x-intercept. Now it must be really slow. And we have the y-intercept. There it goes. Maddie, do you remember how we found an x-intercept? What would you do to get an x-intercept?
You would plug in the y, like you plug a 0 in for y.
Right, to get an x-intercept, you plug a 0 in for y into the original equation. So if I look here, I can see I have an x-intercept at 2 places. So I have 2 x-intercepts, but I have to find them. You can't just guesstimate. We know how to find intercepts by taking the equation and setting it equal to 0. We solved absolute value equation in chapter 1. When you use something in math, you learn something in math, we'll use it again and again and again. It's the way math works. So I'm going to solve this absolute value equation by taking the 1 to the other side. I need to isolate the absolute value bars, so I would divide by 2. I'm going to erase this, give myself some more room. And now I have absolute value by itself, but I need to get rid of those bars. How do you get rid of the absolute value bars? So think back to chapter 1. How do you solve this equation? So we now have the bars, absolute value of x plus 1 by itself. I isolated it. Maddie?
I don't remember if you said right, but is it splitting it into two?
Yeah, excellent. It is correct. We need to split this into 2 equations. So we want to get rid of the bars by separating it into 2 equations. So 1/2 equals x plus 1. Negative 1/2 equals x plus 1. So you're accounting for the fact that I have a side with a positive slope. I have a side with a negative slope. So that kind of accounts for that fact that absolute value has a negative and a positive side of the graph. And then we solve for x. So to solve for x, I would subtract 1. And if I have a half and I'm subtracting 1, I then have negative 1/2. So a half minus 1 is negative 1/2. On the other side, if I have negative 1/2 minus 1, I have negative 3/2. Don't write them as mixed numbers. We're above mixed numbers. So if I have an intercept, it means my x value represents where it crosses the x-axis. We plugged a 0 in for y. Make sure you're writing it as an intercept. So an intercept isn't just solving for x, it's a point on the graph where it crosses over the x-axis. Questions with the x-intercept? That's a lot of work for an x-intercept. So this problem wasn't like just a straightforward, quick problem. It was a good bit of work. Had to graph it, we got to get the vertex, we have an x-intercept. The last one we have to find is the y-intercept. The y-intercept can be found, Riley, by making
X equals 0.
yeah, x equals 0. So we want to find the y-intercept. We have a 2, the x is 0, and then we have the minus 1 outside. So x-intercept is when y is 0. Y-intercept is the opposite when x is 0. So I know this is 2 times 1, which is 2 minus 1 leaves us with 1. And that one you can actually see in the graph as well. So I can see definitely it crosses through the point at 0, 1. Any questions on that? So finding intercepts is something that we talked about in section 2.4 by setting an x or y equal to 0 and finding then the opposite value, the other intercept. So that'll definitely be something that you'll have tomorrow, finding intercepts. Graphing absolute value was 2.7. So that was like not last week, but the Friday before that. Any questions? The last problem on the review worksheet wants you to do a two-step problem. This kind of goes over what we talked about yesterday. So it says to write an equation of the graph. Once as a piecewise function, which is what we did yesterday in class. The second time as an absolute value function, which would have been, again, like a week and a half ago kind of thing. So a piecewise function starts out with f of x, the equal sign, and then it has a little squiggly guy. Grace, how many equations are going to be in our piecewise function?
2.
2. So we will have an equation for the left line and an equation for the right line. Grace, what did you get for the slope on the left side? So it looks like right here is a y-intercept. So what'd you say?
2.
2, yeah. So up 2 over 1 to get to the next point. Up 2 over 1 to get to the next point. So the slope would be 2. The y-intercept is where the graph is crossing the y-axis, and that's at -1. So that would be the equation question.
So how would you know that it wasn't like -2 since the line was
So when you read a graph, you read it from left to right. And I know it's pointed down, but if I'm reading it from the left to the right, the movement of the graph is increasing because it's going up. This side here, the movement of that graph from the vertex on, from the left side to the right is going down. So if a line is going up, it's increasing from the left side to the right side. Good question. Other questions? So if we look at that other line, before we talk about the other part here. So this line goes down to right 1, down to right 1. We need to get the y-intercept. So I need to know when it crosses this y-axis. So I have to go up 2, backwards 1, up 2, backwards 1. We need that y-intercept to make a line. So we're trying to create 2 lines. One on the left, one on the right. The one on the left has a positive slope because it's going up from left to right. So the one on the right side has a negative slope because we went down 2 over 1. And then if I count for my y-intercept, it's all the way up at 7. So remember, the equations, both of them need to be mx plus b form. Any questions writing those 2 equations? Helene, what else do we need for this piecewise function besides the 2 equations?
isn't it the domain?
Yeah, we need the domain piece. So and that's when you go to the vertex and find the x value that's matching with the vertex. Cross all of this out. So right here is the max. That's the vertex. What's the x value there, Helene?
Would it be 1/2?
So
Oh wait, 2.
yeah, it's 2. All right, so at the value of 2, it has a left side, which is less than 2. It has a right side, which is bigger than 2. So when I write the domain, the left side is the part that's less than 2. So x has to be less than or equal to 2 because that's the left side. So think of the number 2 having a side to the left, all the numbers less than it. And then that number 2 has the side to the right, which is all the numbers bigger than it. You can only make one of them have an equal to, and that's a function fact. So one gets less than or equal to, the other one then just gets the greater than. So the left side is less than because that's the part that x is less than 2. It's a -2, a -3, a -4. Those are where my negative numbers are. The right side of the graph is bigger than 2. So that would be a piecewise function. Questions? The last part here says we need to write it as an absolute value function. So that's pretty much the equation we just looked at. Absolute value bars. So we need a vertex and we need the slope. There we go. Maybe. A little slow. So Malachi, do you know what that vertex is at the top of the graph? 2, 3. That's our H and the K value. And then we have the slope. So one is a positive 2, the other one is a negative 2. That's the slope of the two lines. If this graph goes down, is the slope going to be positive or negative in my absolute value equation? So think about that. If the graph is going down, the number in front, when I go to write my absolute value equation, that number in front is going to be a positive or a negative. Leah, do you know? What makes a graph go down?
Oh,
Negative, yeah. So if a graph is going down, the number is going to be negative. The slope is going to be negative. That A value is going to be negative. It's the same slope that's in those two lines. Because when I graph an absolute value, that's what I use. I use the slope of two lines. But it's negative because this graph is pointing down. So my absolute value equation, A is negative 2. And then the absolute value. And then inside, I would have x minus h, which is 2. And then on the outside, I would have a k, which is plus 3. Questions? Please ask if you have any. Yeah.
so how come it's positive on in the piecewise function and negative, but then negative in the second one? Because didn't you say that when you're looking from left to right, it's going up?
The line is going up, but as a graph as a whole. So when you're writing piecewise functions, you're looking at it as two separate lines.
Oh,
But when you're writing the absolute value function, we're looking at the whole thing together as a V. So the entire graph is pointed downward. So if I was looking at this, when I go to graph, my left side has a negative 2, the right side has a positive 2. Sorry, let me flip that. The right side has a negative 2. I wrote it correctly. The left side has a positive 2. But the right side of the graph is always attached to that slope if we were graphing this like we did for the last problem. Yep, other questions? So we're going to do Kahoot today as a little review, just something different. So for those of you at home, if you can go to, if you have the Kahoot app on your iPad, you can use the Kahoot app on your iPad, or just go to Kahoot. So again, you're going to Kahoot. Here it goes. So from home, you can do this. You need another device though. So you will need a second device so that you can see the screen and the question at the same time. And this is just review questions. You might want a piece of scratch paper if you're at home. Oh, you brought a second iPad. Oh, now you have to carry it around all day. Questions? We'll get there. You all are in. Two, that's what I was looking. All right, so I'm going to start. If you're at home and you are not in yet, go to kahoot.it or use the Kahoot app. Maybe write the number down so that you can join. So first question, we're finding the slope of the line, just slope. And it gives you some time. You get a whole minute. So the points are at the top. See if I can make this a full screen to make it a little better. Zero, -4, -3, 2. And if you have a question as we're working, let us know. Good. So just make sure you're watching that minus y2 minus y1. That turns into 6. And then on the bottom, we're dividing it by -3. So just watch the minus signs. You're all competing against those at home. So now we're writing an equation of a line. This is important here. Perpendicular to x plus y equals 10. So think, you have to get it in mx plus b form first because we need to know what the slope is. And then you have to figure out what a perpendicular slope is. So get it in y equals form. What's the slope of the current line? What would a perpendicular slope be? And then we have to use that point, 1 and -3. This one's tricky. Oh, yeah. Yeah. Right.
Oh my.
Okay. That's a good idea. This one's hard, huh? What's the slope of the line? Yeah, this one's tricky. So the slope of the line they give you is -1, but a perpendicular slope has to be opposite and reciprocal. Well, what's the reciprocal of 1? 1. The opposite sign means it has to be a positive 1. So the perpendicular slope has a line that's positive 1. And then if we do point slope form, I would plug in the ordered pair of 1, negative 3. So this turns into a plus 3. My slope is a positive 1. And then I plug in, nope, yeah, that's right. It is a positive 1 and a negative 3. So that's what it would look like. And then you're getting it into y equals mx plus b form. I think that was a tricky question. That might be something you want to look over again. That's section 2.3.2.4. So perpendicular lines. And there were a couple questions on the review as well. Ooh, Lacey moved to the top. Still a strong second over here. All right, hopefully an easy one. Identify the domain. So remember, domain means x. The x values 0, 1, 3, negative 1 in order. Negative 1, 0, 1, 3, numerical order. So domain is x. The D is the first in the alphabet with the x variable, which is also first. All right, linear. Think about, what does it mean for it to be a linear function? What form would it look like? What's the form of a line? Good. Yay, everybody got that one. We're all good with linear functions. So all you're kind of finding here is a perpendicular slope. You don't have to create the line. So if the slope is 4, what would a line be that has a perpendicular slope? Good. Another good one. You don't have to do any work for that. Ooh. All right, this one's one you got to do some work. So write an equation that passes through the points negative 2, 5, negative 4, negative 5. We have to find slope, and then we have to get the equation. So think of point slope form. Use 1 point, plug it into point slope form. So I think if you found the slope there, they all, I should change the answers to that one. Make them all have the same slope or a very similar slope. You let her get ahead. So this is more of a shifting problem. So you're trying to think of the equation that would be shrunk by 1/5 and shifted up 4. Think about that, like what we did last Monday. What does it mean for a graph to shift up 4? What would that look in the equation for? And it had a vertical shrink by a factor of 1/5. So the 1/5 is shrinking the y value of the graph. So when it's a vertical shrink, it's affecting y. The +4 is moving the graph up 4 units. So they're both changing the y value. So anytime we go up 4, it's outside. Anytime we're shrinking or stretching vertically, it's also outside of that f of x, that function. I know that notation is really weird to think about. Any questions on that one? If it's moving left or right, that's when it would be squished inside parentheses with x. All right. Talking about the graph of the absolute value function. So that graph, even though there's a -2 up here, remember x minus is the equation, so the graph would be at 2, 4. So the vertex is at 2, 4, going right and up. This one's a range question. Looks like maybe we'll get 1 or 2 more in. So what's the range? Good. Range of the y values of the graph, again, in increasing order. This one's talking about direct variation. Direct variation is of the form y equals a times x. So you're supposed to come up with the equation. So they give you an x and a y. We need to plug that in and get the equation. So essentially we need to find a and then have the equation. This was question number 7, I believe, on the review worksheet, similar to number 7 on the review worksheet. So if you're not sure about this, it's something to look up tonight. This is in section 2.4. It's like the second part of 2.4. So I would plug in the 4, I'd plug in a 1/3, 4 for y, 1/3 for x. And when you solve for a, you get 12. So again, that's section 2.4. If you have questions on that, look up 2.4 tonight just to kind of review 2.4. We're going to do one more problem. Ooh. This is another good one to end with. So this time we want to come up with an equation of a line that's parallel. So think about what has to happen with a parallel slope. You need to find slope first. And then the point is negative 4, 4. So we want the line that has this parallel slope. Again, that would be section 2.4 as well. We did a lot in section 2.4. So using y equals mx plus b, or the point slope form, y minus y1, mx minus x1. So the slope of its parallel. Parallel means the same slope. So I have to use the slope of 1/2 and then plug in the ordered pair of negative 4 and 4. Questions? All right, so I'm going to end the game. Let's see here. Nice. 10 out of 11 questions, not too bad. Gabby at home, nice job. Valerio. So Jordan Riley, runners up. Just a little information about tomorrow. I will have office hours tomorrow morning from 7:05 to 7:20. So if you realize that you have questions that you want to ask, you can join Zoom. There's a special link for Zoom at the top of my Google Classroom. And it actually says, I think, Math Help Monday or Monday morning, no, Wednesday morning Math Help, I think it says. So tomorrow, if you have questions before the test, 7:05, you can pop onto Zoom by clicking the link in my Google Classroom page. It's at the very top. So I like 4 important things at the very top of the Google Classroom page. Test tomorrow, you do not have to join Zoom tomorrow. So if you have questions, join Zoom. If you want to take the test with me, in case you have any tech issues, you can join Zoom. Madison.
What time is like the Zoom instrument? I looked on Google Classroom at like the weekly thing. It's 7:05 or something.
Right. So tomorrow you can join at 7:05 if you have questions.
Oh.
Only if you have questions. But 7:20 is when class starts, just like it starts today.
Right.
So again, if you want to join me on Zoom at 7:05, there's a special link for tomorrow for Wednesday to join for Math Help. Any questions that you have. And then the regular class starts at 7:05, but you have a test. So you can just start the test, or you can log into Zoom in case you have tech issues. I will be there either way on Zoom. So if you do have a tech issue, you can come on and ask a question. Other questions? I'm going to try and pull up the announcements again, see if they work today. Well, that says 10:06, must be good. See if it works.
Just for you, I sing happy songs. navigate with the Tribe Daily. Here are the announcements for the week of October 5th. Spirit Week begins today. The themes are as follows. Monday, your class colors. Tuesday, USA Day. Wednesday, your PJs. Thursday, North Hills gear. Friday, your neon and tie-dye. The flyers can be found in your Google Classroom. Hybrid instructions start today, Monday, October 5th. First period begins at 7:20. Students with the last name starting with A through L will be in attendance today and Tuesday. Students with the last name starting with M through Z in attendance on Thursday and Friday. All students will be virtual on Wednesday. The schedule will continue to begin at 7:20 for virtual Wednesdays. All students must fill out the district attendance form. A link can be found in your Google Classroom page. Please ask your teachers if you need assistance with attendance. Now please be quiet for a moment of silence.
Remember, before I forget, if you want lunch, scan the QR code on the top over there. Have a great day. All right, have a good day, everybody. You too. Thanks.